Hello and welcome again to Chemistry with Mr. Olson. Today we're doing some more problems from our heat worksheet having to do with heat. Okay, so let's scroll on down and let's see. Our equation is in question 13. Question 13. The equation used to calculate the heat gained or lost by an object is Q equals mc delta T. And in our textbook they use S instead of C. I don't like that. The rest of the world uses C, so we're going to use C. Question 11. The symbol for heat energy is Q. Specific heat capacity is C, except in our textbook it's S. And temperature change is delta T. Delta T, change in temperature. Specific heat capacity, in question 12, is defined as the amount of heat energy, which is in calories or joules, it takes to raise the temperature of 1 gram of a substance, whatever substance we're talking about. Each substance has its own heat capacity by 1 degree C. So, specific heat capacity is the property of the substance. Water has a very high specific heat capacity. Metals generally have a low specific heat capacity. Okay, so let's do a couple sample problems using this wonderful equation. And to do that, we're going to zoom way in. And here we have question 16. Question 16. Iron, 350 grams, cools from 27 degrees C to 12 degrees C. Calculate Q, the heat flow, in joules for the iron. Okay, let's do it. We'll calculate Q. Well, we've got the equation. Let's try to start on the screen here. Q equals mc delta T for the iron, and they ask us to calculate Q, so formula equals, and now we substitute. Do we know the mass? Yes, we know the mass of iron. The mass of iron is 350 grams, 350 G. C, specific heat of iron. Well, that's written on the very back of this worksheet. We have the table, 10.1. Iron is 0.45 joules per gram degree C. So, let's write that in. So it doesn't blend in with the others, I'm going to change colors. 0.45 joules per, so let's put this per gram degrees C, and times mc delta T. What is delta T? Well, actually, delta T, we need to calculate it. What was the change in temperature? The equation, which I'm asking you to memorize, is delta T equals T final minus T initial. Equals, formula equals substitute. What is T final? Well, our iron ended up at 12 degrees C. So that's our T final, 12 degrees C, minus T initial, 27 degrees C. And 12 minus 17 equals minus 15 degrees C. The sign is important. That means the temperature went down, which indeed it did. It was getting cooler. Okay, so that is our delta T. Let's write that in our equation, mc delta T. So I'm going to put it in parentheses so it's clear that we're not subtracting, we are multiplying by minus 15 degrees C. And now we just multiply, but first we cancel units. Let's see. Grams over grams cancels, and let's see, joules, degrees C on top, degrees C on bottom, cancels. So now we do the math, and we'll do a continuation equal sign here, continuing our equation. It equals Let's see, something to 2 sig figs, 2,400, and our units are joules. So box our answer. This worksheet actually very nicely provides the answers on the back. Let's check our answer. Oh, I made a mistake. I forgot the minus sign. Ha ha ha. Well, I'll fix that. Minus 2,400 joules. Okay, so we have 2 sig figs because 350 has 2 sig figs, and so does this other measurement. Okay, that's question 16. Let's do one more. This is a little tougher problem, and it is question 20. If 120 grams of aluminum at 21 degrees C gains 310 joules, what is its new temperature? So this problem, here's the advice. 2 steps. First find delta T, and then solve for T final. Okay, so find delta T. Well, I know, and I'm going to write this right here, Q equals MC delta T for the aluminum. So what does delta T equal? That'll help us find the temperature. Delta T, solving for delta T equals Q divided by MC. We divide both sides by MC. Let me switch colors so that our equations don't run in together. Delta T equals Q over MC. So there, formula equals substitute. What's Q? Well, 310 joules. Positive 310 joules over M. So what's the mass? 120 grams of aluminum, 120 grams. And C, specific heat of aluminum. Well, we'll have to look that up. We're using joules, so this table is in joules. Aluminum, 0.89 joules per gram degrees C. So let's write that in. I'm going to write it in blue so it doesn't run together with the other stuff. What is... Okay, C is 0.89 joules. Now, rather than introduce another divisor line, I've got one. The joules over grams degrees C is just on the other side of the divisor. So, joules per gram degrees C. All right, now let's see if anything cancels. Grams over grams cancels. Let's see, joules over joules cancels. And we're left with degrees C, which makes sense because we are calculating delta T. So equals, and what does that come to? Get out our calculator. 310 divided by 120 equals, divided by 8.89 equals 2.9 degrees C. All right, but that's delta T. The question asks, what is the new temperature? So we have a little more work to do. We need our delta T equation. Let's start a new color. I love the colors. Delta T equals T final minus T initial. That's the equation we memorize. Solve for T final. So we'll add T initial to both sides, and we get this equation. Let's make it a lovely green. T final equals T initial plus delta T. Formula equals substitute. What's T initial? It started out at 21.0 degrees C. T initial plus delta T plus 2.9 degrees C. Do a continuation equals here. Equals 23.9 degrees C. Box our answer in this long, complex calculation. And actually, this worksheet lists the answer on the back. Let's check. 23.9 degrees C. We got it right. Terrific. So, remember, whenever you use this equation, Q equals MC delta T, whenever you use that, it has to all refer to the same substance, and delta T equals T final minus T initial. Keep those straight because the sign of delta T matters. So that concludes our video. I hope it's not too long. Have a beautiful weekend. There we go. Ta-ta.